Hello.
Hi, I can hear you.
Yes. Any question today?
Yeah, I was wondering if we could kind of go over assignment 6.
Assignment 6. Okay, no problem. How about the previous one, the 5 and 4? Okay.
I think I'm okay on those. I'm planning on getting those all turned in tonight.
Okay. Number 6. Number 6 is cylindrical manipulator. Jacobian. Okay, so we say that it actually is cylindrical because that this one you do have rotation, right? And when you do rotation, it has an extender. So basically, it is making a circle, but it is extend. Okay, extend. Okay, we do not have an extender going down, but it actually is this one. It's actually a surface like donut shaped surface over here. Okay, it doesn't go down. Okay, we do not have the third dimension, but it's a simplified cylindrical manipulator. So the goal for this one is we do want you to go through this cylindrical manipulator and then go through the design for the Jacobian metric. So you need to derive the Jacobian metric. And I believe that in quiz 6, we do have that hand calculation formula. You need to write it down by yourself, right? And then use that and plug in into the algorithm that we give you to generate the Jacobian metric. And then put that into the Python file and Python program and just do coding. Which part you have question? Let me bring up the Jacobian. Okay, I'll take question one by one. Okay, I'll take question one by one. So when I finish this one, someone has question, you can just voice out. Okay. So this one Jacobian. So basically, you need to have the kinematic diagram for that cylindrical manipulator, and then you need to derive the Jacobian. You need to derive the Jacobian. So we do have one revolute joint and one prismatic joint. That's it. It's not really hard, but you have to go through the process to derive the equation and put them into the Python program. Okay, that's it. So you need to download this one or watch the video for this inverse Jacobian metric. Let's see. So inverse or regular. Let me look at it. Okay. This is inverse Jacobian. I think it's actually Jacobian. You need to work on the Jacobian first. Let me see which part it actually is required. This one, it won't the Jacobian, not the inverse. Okay, I'm sorry. You should actually download this one, Jacobian metric. Similarly, you need to derive the equation and then put them into the formula. Put that into the formula and get following the procedure here to get the so-called Z vector and the O vector, and then do cross product and put a number into there. So there is a simple code. You just need to go through it. That will be good enough. Okay, for this one, for this assignment 6. I think inverse maybe is assignment 7. Okay, this one okay. And Nick, okay.
Yeah, I think so.
Okay. Next question. Anybody has other question? Any other question?
Yeah, I guess I have another question.
Yes.
In regards to my final project proposal, I didn't realize you left a note on it until like a few days ago. And I guess like my writing was a bit too rough, and I was just wondering what more would you like to kind of like talk about, just so I could because I think it would be helpful to me more. I've been working on my final, but I think redoing my proposal will still help me get a better grasp on it.
I think that for project proposal, we do have a video for it, right? You need to at least, the minimum requirement is to in actually week 3, we do have video for the term project proposal. You need to follow the format that we require over here. Okay, you need to actually put them in requirement. Some students actually just write whatever they want, but here we do have the detailed description of what need to be included, right? And the topic wise, as long as it is related to robotics, we are okay. Okay, it actually may be a mathematical model or assembly project or creative project. Okay, so the project wise, you need to describe what you want to do. You want to actually come out with a mathematical model, you want to assemble a robot, or you want to create some new idea and talking about the feasibility of some creative idea, that's actually fine. Okay, that's actually fine. But that's the possible project idea. But as long as it's related to robot, it's welcome. Okay, it's welcome. And now the format for the format that we want you to actually provide, at least in this there's a video you can watch, right? That's number 1. Number 2, you need to give me the project goal. Okay. Second, you need to give me the schedule. Some people don't give me the schedule. You just talk about, I'm going to build a robot, that's it. And then don't talk about how are you going to do it and what material you need to have and what tool you want to use. So basically, this is a project proposal. Okay, assuming that you are asking money from your project manager or your boss, that you're proposing something to them, say you're proposing something to them and ask for money. And I'm the person who grant you the budget. So why should I give you the money? That's the problem. So you need to tell me within so much time, I'm going to do this. Okay, so your project idea and title and what you want to propose, what's deliverable after 3 weeks, 5 weeks later, what you will do. And then your tool that you want to actually use, the material, software you want to use, material, and your schedule. These are what required for proposal. We don't need you to actually write technical papers. So some students do copy from some technical paper. That's wrong. That's totally wrong. Put it out of quotation. That's actually totally wrong. We don't need you to quote any paper. It's not technical. It's not technical writing. I don't need to read technical publication for a robot. That's for academic environment that you actually write technical paper to submit to conference or submit to some journal paper, right? Journal, IEEE journal or mechanical engineering journal. We don't need that, okay? We don't need that. We don't need you to write me the technical writing, not a technical paper. So do not give me tons of theory of what actually I quote is a professor, that professor. I don't need that, right? I don't need that. My requirement is very clear. Your project title and idea, what you want to achieve. I want to build a robot. That's very simple. What kind of robot you want to build, okay? And what purpose that my robot would do, right? You describe it clearly what you can do within the 7 weeks, 5 weeks time, and what you want to deliver. You don't have time to build a robot, that's okay. You want to build a mathematical model for a robot, okay. You actually just need to describe what you want to achieve. So do not actually tell me that I'm going to build a robot and then I can send it to Mars. I don't need that kind of project, right? I don't need that kind of project because you're copying from somewhere else. We don't do that, right? We don't do that. In this proposal, we don't need you to promise that you are going to build a robot arm that actually can be used for NASA in the outer space. No, we are not doing that, right? We are not doing that. We are not doing that. We are doing something that you can achieve, you can do at your environment using the resource you have. No matter it's a mathematical modeling, you use the 3D blender, you use whatever software tool you can choose, AutoCAD, whatever you can do to build 3D blender, or you actually build a robot, or you actually come up with some ideas. So describe to me what idea you have, and then what's the contribution of your new invention. Okay, so this actually we talk about it pretty clearly in our previous lecture and also the video. Okay, we have pre-recorded video covering that. We also have the in the discussion session, I also discussed it once or twice before. So basically, whatever I am judging is based on this criteria. Okay, based on these criteria, whatever score I actually just copy here. Some people just copy some technical paper from someone else. You may get deduction because you are not following my requirement. It's not a proposal. So you propose a project to your manager, and then that proposal is full of technical paper by other people. That's not a proposal, right? That's definitely not a proposal. And actually, we do have the final report. So the final report is after you finish this project. The proposal is before the project, and final report is after the project. In week 8, we need you to finish the final report. So final report, you need to sum up what you have done. And this one you want to discuss in the technical writing, that's fine. Okay, you want to quote people, this one you can put it there, because this one is the final report, it's a technical writing, and also need to present your achievement. So this one, put in quotation or put in your theory, that's fine. Put in your technical file, your YouTube link, that's actually fine. Okay, PowerPoint presentation, these are required. But in proposal, you don't need that. Proposal just a proposal of the idea. And the whole purpose of having you to do this is that just give you the idea of later, after you graduated from Lewis University, you go to a job, right? You need to make proposal to your manager, your director, your VP. What kind of proposal you need to propose to them, and how you can win money from them, win the budget from them. That's the whole purpose of doing this. Okay. And if you just write me something, okay, you just give me a later size paper and then write down your name, and then I want to be a robot. I don't think any manager will give you the money to do that, right? No, they won't. They want to see that, okay, your project is promising and can really deliver something before they can grant you the money, right? The budget. And Nick, is that okay?
Yeah, thank you.
Is that clear enough?
Yeah, I think so.
Okay, and the final report, we say that actually is the summary of your result. So you do need to write the technical writing, what program you have done. You actually be a robot, and it's actually, you can manipulate it. So take a video, put it in YouTube, and then send me the link only. I don't need your video file. I don't need that. You actually give me that. Oh, okay. If you don't know how to make video, you send me a PowerPoint file. That's also fine. So a presentation, a final report, and the technical file. These are 3 elements that I'm looking at the final report. Suppose that this proposal and the final report are related, okay? But in case that you change your mind in the middle, I'm fine, okay? I'm fine. I'll grade them separately. So if you say, I'm going to build a robot to the moon, robot arm for outer space, but you figure out that's actually impossible for you to build within 5 weeks, and you change your mind, and you decided to build a Lego robot, that's okay. We do not need you to actually be 100% the same on your proposal and your final report. Proposal just asks for money, right? And final report is what you have done. And you change topic is fine. We will actually grade them separately. Okay. Is that okay?
Yes, I think so. Thank you.
Okay. Other question?
Hi, Professor. This is Raju.
Yes. Yeah, how are you?
Yeah, I'm good. Thanks for asking. How are you?
Yeah, I'm okay.
Actually,
Question?
I have one doubt regarding the final report.
Yes.
Do we have any specific format to make documentation? Actually, it's like IEEE or
As
any
long as
ATA.
you are using popular software, say PowerPoint or Google Doc, okay?
Okay.
Google's what's that? Google's Sheets, Google Doc, the Google Toolkits. I'm fine, okay? The Google one or you use Office one, I'm okay. Either way, it's okay. And
So we need to,
yeah, YouTube is optional.
okay.
YouTube is optional, so you can look at you can look at the every year I do pick up the whoever give me the video link. Okay, so remember that there is a recorded session. We do have I teach this. This is the third year I teach this course in Louis. Okay, let's pick the last year's recorded session, right? So let's move down to the, okay, so every week I do have some discussion of whatever I have taken. So here there's some student name. So these are the video that some people actually have done. So let's look at this one. This one is very interesting. It's totally robot, okay? So this one, let's look at this one.
Okay, here
Can you
is
hear it?
my final project.
Yes,
It is the
yes.
toilet
Okay,
robot.
so this guy
It
built
is
a toilet robot.
that is designed to play music while you are using the toilet, as well as close the lid when you are finished using the toilet. And so before I plug it in and show you how it works, I want to talk about a design philosophy that I use. And because a lot of things are going to happen when I plug it in. So I like to check everything is working and let the user know that everything's good before it actually starts anything. So what we're going to see, it's going to be difficult to catch, but these two lights are going to turn on to show that they're functional. This music is going to play. And this servo down here is going to...
Something wrong, okay?
Okay.
Okay, I think
So
the internet is interrupt or some reason. I don't know.
Engage and set its position to.
But okay, let me
zero.
stop it for a while. So basically, he's trying to present in his idea how he built it, and then what material he's using, and then how it function, right? So far he's still introducing the electronic system. So he shoot this video, and later he found out that actually this one he doesn't show it with the. He just actually play around, and actually it's just using his hand to demonstrate that he can sense his emotion. Okay, but actually he didn't demonstrate that when it's used in the restroom environment, toilet environment. So his idea is that okay, there's a person go to the restroom, and then it will trigger the auto music player. That's what he has. Okay, no matter how he come up with this idea, but that's the idea he has. So he tried to demonstrate this board and demonstrate that it's actually workable. So he shoot this video for the first time, and then later he found out that his demonstration is not enough. So he actually, after like a week or something, he showed me a second video that actually he really has put it in the toilet environment and then make it work.
Not to move.
Is that okay?
So it's changed to the red state, and we can.
yeah. So we need to make a recording session. What I have done.
So no, this one is one of the example that actually. Okay, so this one actually is the first version, right? There's another version, it's an update version. So later he showed me another version. Okay, later this update version. So this video you can actually find it. Okay, now he's put it in the restroom environment.
Okay, so here we have our toilet robot in action. I've upgraded the servo to make it more powerful because the previous one I was using, the blue one, was not powerful enough. And So I've also switched to using command strips down here because the tape wasn't really strong enough. So the command strips was actually a pretty good idea. So what we're going to do is we're going to pretend we're going to begin using the toilet robot. And so the robot has detected that we are here. And then I'm going to hold the robot down just because it's so powerful, it will push itself backwards. It's not heavy enough. Okay. And so there it goes. The robot has closed the lid to the toilet. And that's it in action. Thank you very much.
Okay, so basically we know this is
Okay,
actually
so here we have our toilet robot.
okay. Basically, we know that this one is actually a demonstration of idea, right? And as long as you know how to present it, that's good enough. It's not a product, so we do not require you to give me a mature product that actually bug-free, and then so we don't need that. As long as you can tell me what you are trying to do and what you have achieved, that would be good enough. Is that okay? Video would plus, actually video is good. And I look at the creativity. I don't look at I could look at the creativity more than the completeness or more than the technical difficulty. Is that okay? So that's actually one good example of that year. Let's look at the year 2020. So these are actually, you can find them in the past year. You can all look at the project that somebody has done before. I always put them every year, okay? So let's see, there's some other student, okay. Okay, everybody are very creative. Okay, so let's see, let me pick okay, let's this is Pinko. So this guy, apparently he has more money, right? So he actually do get a robot, okay, and make it work. Okay, and I told them that do not get the robot that actually you build some for some other course or borrow from someone else. Okay, don't do that. So he actually sent me the design file he has. Okay, to prove that this one is actually he designed by himself. So we do not limit you to do whatever project you need to do. These are examples, and they are also students. They actually don't have time to build robot, and actually say, okay, they actually buy some robot.
Hi.
Okay, so he actually built a Raspberry Pi robot. Okay. Okay, apparently this guy did not spend enough time, so but he tried to do presentation. We would grade based on how much effort he had done and what he has done. Okay, and okay, presentation is a make-believe game, right? So you try your best to actually demonstrate it, and some actually demonstrate the car.
I've installed the obstacle sensor, and every time I place this light in that paper, the type that is going to move up depending on which direction. And if I go right, I go right. If I go left, I go left.
Is that okay? And they are students just build mathematical model as well. Okay, so that actually we already show it. We already show it in many of the video courses. So I just demonstrate these related to a robot project. Okay, any question?
No, Professor, I'm good. Thank you.
Yeah, so basically that's the summary of your project, okay? But do not copy a lot of things from other people. I'm not, well, I don't need to read those technical reports from someone else, not related to your project, right? I just need you to tell me what you have done in the final product. And then in the proposal, I just need you to show me what you want to achieve. These are very, very simple idea, okay? I give you this training for the proposal and term project. The whole goal is to help you that someday you are going to go to a job, right? And when you are going to the job, your manager or your boss or your director do not have time to listen to your 2-hour lecture talking about what you read from other people. Okay. People's time is very important. So you need to the point. You need to be cutting through the point right away. You need to use the 3 seconds to build up catch their eye. Use the first minute to actually win their heart. These are something you need to do, okay? Do not write a lot of garbage and then lose the focus and then trying to convince people that you are the best project on earth. You don't need that. You just try to cut to the right point, show people what you want to propose or show people what you have done. Is that okay? So do not try to collect a lot of paper from other people. I mean, give me a 200-page dissertation. Okay, why should I read that? Why should I read that? Why should I believe that you actually finish 200-paper dissertation within 8 weeks? Right? It doesn't prove anything. It just prove that you try your best to copy. Right? I don't think that a person can finish 200-page dissertation within 8 weeks. That doesn't make sense, right? So we are not training people to actually create those documents or create PowerPoint. We are not training PowerPoint engineer, right? We are not. We are training people who actually try to be a real mathematical model or be a real machine. So I need you to write the proposal or your project, term project technical report right to the point, but also do not try to write a proposal or a report that's too short. Say, give me 3 sentences and then try to finish things up. That actually is not a report, not a proposal, right? That also is wrong. I need you to be actually concise, stay clear what your goal should be, and give me the real meat in a very short time. Is that okay? Always try to do that, okay? No matter where you go, always present the meat only. We do not need the garbage. Don't just try to stuff a lot of things into your project or your proposal. You can only confuse yourself. You won't confuse your professor, or you won't confuse your boss. Their time is very precious. They are successful because what? Because they manage time well. If your manager actually would spend time to read your garbage for 2 hours, right, and still don't know what is important, what's not important, I can guarantee you that's not a good boss or not a good professor, right? A person should be able to make judgment maybe within 3-5 minutes, knowing about what's important. If they are really interested in your project, they will look into more and spend another half an hour or 1 hour to see, right? But definitely, they don't actually go into your project right away to spend 3 hours to just study it. They don't. So you must use your time wisely. The first 5 seconds, 10 seconds, you need to catch their eye. The first minute, you need to make things pretty clear to them. So don't try to confuse them. You can only make your project confusing, and you can only confuse yourself. You can never confuse someone who is very successful. Say you try to talk to Elon Musk, right? They don't give you, no, those kind of people don't give you a lot of time to actually present whatever you have. They just want you to see what's important to them, what's the benefit they can get, what's the impact you can make, right? So you need to cut short, to the point. Okay, these are some guidelines I want you to actually just want to share with you. Whenever you go, you try your best to try to actually cut short to something important. Okay, to try to do something important. Do not try to actually do something that actually what? Just confuse yourself, confuse people, that actually will waste time. Okay, so same thing for the project or the proposal we talk about. Just write on the money. We want to see what you have tried, what you have done. No matter how humble it is, you present your best. Okay, you present your best. You do your best and present your best. Okay, there's no need to compare with other people's project here. Just some project idea, okay, or something that other people has done. You can look at the video. Okay, you can look at the video. These are previous, some good ones, some bad one. As long as they show me a video, I'll put it in here as a collection. And not only this course, these are the courses that I teach for robotics. I also teach the programming language. So over the past several years, say let's look at this course shell, the programming language one. Since I keep the past year's project, every year I accumulate a video. Whoever had done what project before, I all collect them. So when students ask me, what should I do in my final project? They are all there. You can look at what people has done before. And because I'm not afraid that you actually try to look at other people's video, because we want you to work on something new. So you copy from their idea, it doesn't count, right? We still don't want you to actually use some people's old project to do it, right? Is that okay? Any other question? Any other question?
I have another question. I was
Yes.
wondering if you could go over assignments 7 and 8 for the programming assignment.
Program mean assignment 7 and 8. Number A, I think is going through the whole thing, right? That actually is a final modeling. So 7 is more important. A actually is summary of the whole thing. So as you can see that our project from week 1 to week 7, there are 7 different kind of the robot, from easy one to harder one. Okay, from easy one to harder one, and then we go through different topic. Okay, so this one actually is number 7 is the inverse Jacobian. Okay, so inverse Jacobian's main purpose is to predict the past. Okay, so this one there's no revenue join. Everyone is actually a what? A prismatic join. So here you actually, if you do not use the metric, you can use your common sense to predict how fast the things should be moving. You can use your common sense to predict, because it's always just SYG transition. So basically, the whole thing is like you need to model this manipulator, and then derive the inverse Jacobian, okay, and then you try to come out the equation for the D1, D2, D3. These are actually a dot on top, so it actually is a speed, the speed function for the displacement. So basically, how fast this thing is moving, how fast this is moving, how fast the D1 is moving. Okay, these are actually a function these. Okay, so you do have B1, D2, these 3 different things, and you need to predict where the thing will be moving, SYG, according to D1, D2, inverse is from SYG, go back to check to get the D1, D2, this different D value. Okay, let me check. So this one is an inverse Jacobian. So right here, we do have another one, different one, but basically you need to derive the Jacobian metric, right? And then from the Jacobian metric, it derives the inverse Jacobian So you actually find out your Jacobian metric first. And then from your Jacobian metric, you derive your inverse Jacobian metric, right? And from there, you have this variable and your change. Okay, so these are control variable. These are your state control variable. Okay, these are your actually positional change speed. So here it's not θ1, θ2. Actually, here it's d1, d2, d3. So given this the control variable different speed on the three joint, what speed you will observe? What speed you will observe on the object? So given that you are actually your joint are moving at different speed here, here, and here, what would be your endpoint speed for SYG's change? SYG is location, but we would like to find out the speed change. So there's a dot on top of it. It's a derivative of that. So you need to derive the so-called inverse Jacobian metric and then try to figure out this. So I think that you can study for all of the lab and homework. We do have similar but not the same one. So you should watch this video. And they are sample code, but the sample code you cannot directly copy. I think there's some change you need to have. So the one that we actually show you, maybe is this one, maybe is giving you two revolute join, but the one you need to work on is different. The one you need to work on actually is a three prismatic join, all prismatic manipulator. Okay, so and assuming that the A1, A2, A3 are all one. Okay, and that's the purpose for number 7. And number 8 is a review project. Number 8 is a review project. It's the largest project, but it actually had nothing new. It's a review project. So this review project is, we do have the so-called cylindrical arm and the spherical wrist. So they are two part. So arm is here, wrist is over here. Okay, so arm, we say that what is arm? Arm is the location of your end effector here. Okay, SYG here. So this spherical wrist is just changing the orientation of your endpoint. Rotate, up, down, left, right. Okay, it's your endpoint rotation. So the major SYG is determined by your arm, by your cylindrical manipulator. Major SYG is handled by this. This one affecting the orientation for your final click. Okay, so here this one is rewrite assignment. We have discussed the cylindrical arm and the spherical field. So there are 7 steps. You need to generate the whole thing, starting from kinematic diagram and then whatever things, okay? And then you need to derive then will be Hardenberg table, okay? And then create a table, whatever. So do step by step and analyzing this 6 degree of freedom robot from step 1 to step 7. And these different steps are described in the video. We do have video for this one. You have to read it. So it actually is 6 degree freedom kinematic. So it's actually something that is, we do have a video in the lab. You need to figure out. We do have the video and also sample code to talk about the first 3 degree of freedom manipulator. These are the arm portion. Okay, so this is PRP, RRR. cylindrical arm spherical wrist robot. Okay, an example of that. And we do derive everything. So I say it's a rewrite project because you need to follow the step 1, 2, 3, 4, 5, 6, 7 here. So we do not ask for new thing, but we actually need you to go through the whole process from 0 to the end by yourself one more time to integrate the whole thing together. Is okay? So you definitely need to watch the video, the whole thing, before you can work out it completely. So this will give you the whole idea of what you have learned in this course. The mathematical modeling on a cylindrical manipulator and spherical wrist. And there are two parts, arm and the wrist. And we separate them to do analysis. And then the whole 7 step is described over here, 1, 2, 3, 4, 5, 6, 7. Okay, these are very hands-on experience. So there is no super hard theory, nothing. You just go through it step by step. And everything is reviewed. It's basically 7 steps, almost like you review chapter 1, 2, 3, 4, 5, 6, 7. Right? Is that okay? You week 1 to week 7, you review one more time. I want you to put it together so you actually review the whole thing one more time to see how the whole robot starts. So I say that some people use it as a term project because they try different robot. They try different 6-degree freedom robot, but not this one. It's acceptable. Yes, it's acceptable. We do not require you to must use a super robot build by yourself. No, we don't need that. You actually provide a mathematical model is also acceptable. Some people did it very thoroughly, very completely. Yes, they are good project before as well. Any question? Is that okay?
I think so. Thank you.
You have to find this a different video. Okay, you have to find this a different video, and they do have a sample code you can download. But this one we are okay. We don't care about you actually follow the whatever code we have, as long as you learn something. Okay, you want to write your own code, it's okay, but do not copy code from each other. Okay, I don't like it. The whole thing is that actually you take away your chance to learn. Okay, so for this course, we do generate tons of the video. Okay, tons of video to help you to study different part of the robotics. Okay, and it is a 8-week course. It's really too short to swallow so many things, but we don't have option. Okay, we cannot extend it for 16 weeks. We cannot do it for 2 semesters. We are assigned for 1 8-week term to finish it. Okay. Okay, other question? This one is the number 8. Number 8 is a review project. It actually is going through your whole semester to review it one more time. Okay. Any other question?
Yeah, I guess I had one last question.
Yes.
So everything needs to be turned in by Sunday of next week, right?
Sunday night, 11:59
Okay.
Central Time. So I'm required to do this. Okay, I'm required to submit the whole grade. Every year, every semester is the same. Usually they require me to turn in the final grade before the Tuesday 8 a.m. Right? So I don't do grading like 7 a.m. in the morning Tuesday, right? So the whole thing is I have to finish it, all of the grading and send it to the university before the end of Monday. Right? And to be fair, I need to use the Sunday night 11:59 p.m. as a cutoff time. Anything after that, I don't take it. Don't ask me, hey, I just actually passed, I submit on 12:03 a.m. on Monday. Is that okay? No, it's not okay. I told you this is still a sure daytime. This is dead time. Okay, we don't take anything after that. Okay, so you try to submit as much as possible before that. Any time before that, I'll grade it. I still have the whole Monday to work on grading, right? So actually, I don't want people to submit on Monday, because you submit on Monday and then what? I still need to. They are, well, the first year or second year I teach, I do allow people to do that. Then the whole Monday I'm not actually sleeping. Okay, I just keep wake up by some student like chasing around just to do grading for you. I don't do that anymore. Okay, is that okay? Give me the whole day to grade it. That's more important. I need to give you the not only grading. There are so many homework. I need to finish the grading. I also need to tabulate your final score and then also submit the score to the university. Right? It take a while. It take quite a while. And this is not the only job I'm doing. I still have some other job I need to do. Okay. This is only. I'm just a part-time teacher. So I do have my own personal life and my own other thing to do. So give me some time to finish it. Okay. So basically, Sunday night, the end of Sunday night, definitely not going to take anyone. For so many years, I never break this rule. Okay. I never break this rule. Is that okay?
Yes, thank you.
But if you give me the week one assignment on Sunday noontime, I'm okay. No matter what reason it is, I'm okay. Maybe I deduct you 5 point, 10 point because you're late, to be fair for other students. But I don't give you a 0 if you actually are late. I encourage people to work on it. Okay, but if you are late, you actually missed the Sunday night 11:59. Sorry, that's a sure deadline. I don't extend, and because the university do not allow me to extend as well, I also need to submit grade. We need to do it following the requirement. Okay, is that okay?
Yes, thank you.
And I finished the grading for this course, right? 18, 19 of this month. And then soon, January, I have the programming language course. Need to start it next for the next semester as well. So I need to prepare for my next year's teaching, right? So that actually come for spring 23. It's coming pretty soon. So I need to get prepared for it as well. And there's one thing I do want to point out. There's one thing I do want to point out is the grade book. Okay, it's a grade book. So far, I'm happy. Nobody asked for this one because most of you, I think, are very technical. That's good. Okay, they are not student ask me for this. What's this participation point? Okay, so far very good. This course, nobody actually asked me this question. How am I going to grade this one? So basically, this one I don't like the student to ask for too much. How I grade it. Okay, so basically, totally say we do have say 3,000 point base point based on all the homework or your assignment or whatever discussion. So this final 300 point is add on. Okay, this is final 300 point would be add on. And then how are we going to get it? Okay, so say let's assume that there's a student who get 2,700 point over here, right? Base points out of 3,000, he get 2,700. Okay, and then this 300 points somehow I assign him 100 points. So this guy will get 2,800 for total point divided by 3,000. So this one would get a 90 something, something, something. I would give the grade based on this 90 something. Is that okay? So the divisor is the base point. Doesn't include this 300. That's the rule number one. So this 300 point are bonus. Okay, this 300 point are bonus. Okay, and how am I going to get this 300 point? Rule number one, the whole class attendance. Okay, how many people attend this class? How people behave in this class? I based on the class attendance, and then how good they do work on it. Okay, and I may give everybody same or different grade depending on their attendance and their reaction and response. Is that okay? And because it's add-on, it's not your own, it's not something you can work on. So I usually do not discuss it. So usually what I'm using it for, okay, one is like how the whole class behave. Second is like there are certain year, the whole class is very low. Then I also use this 300 point to curve up the whole class. Okay, let's assume that actually this class at the end, we do have 13 people. Okay, let's assume that we have 13 people. If this class at the end, we do have 12 of them actually we got C and one guy will got B. Okay, so basically I'll try to bring up the whole class point using this extra point to bring up. Okay, but if these 13 people, actually there are 12 A and then 1 B. Okay, usually I may not curve that much. So this one also, sometimes I'll use it to curve the whole class. Okay, is that okay? My duo usually is I try to control my A between 1/3 to 2/3. Okay, I try to control my A minus, A plus to be within 1/3 and 2/3. If a class have more than 2/3 that's HA, I think that's ridiculous. Okay, that's ridiculous. I can just give everybody A, okay? Because there are some students do not submit homework. And I just give everybody A. That's actually doesn't make sense. And if the whole class actually got a C, I don't do that, okay? That actually, that doesn't make sense. That means that my material may be too hard or something. So minimum, I would say they should be more than 1/3 should be A. Is that okay? And how much, I don't know. How much actually, I don't know. I have to look at the whole group to decide. Okay, I have to look at the whole group to decide. But I try to control my final number of A within this range, using this to curve. But if really that you guys are too far off, then more than that I can rescue you by this 300 point. I'm sorry, then I cannot do that, right? So you have to within certain range before I can actually help you. Is that okay? Hello? Is that okay?
Yes.
But one thing I can guarantee, here I don't give you negative one. Here I don't give you like -10, okay, no. Here you can only take maybe 100, maybe 50, maybe 200, I cannot guarantee. But basically I'll use that to curve the whole class, okay? There are certain students work super hard. Yes, I do see some people before. Then I will actually give them extra bonus point. It happened before, yes. Any question? Any question? So far, this class is not too bad, okay, compared to some past classes. this group of students, I think it's not too bad. Okay, that's the only thing that I can say. Not too bad. Work harder, okay? Work harder. We actually expect you high, so we actually give you more pressure, more thing that want you to do better, okay? But eventually, our curve based on whatever the class is, okay? Any question? There's one good thing is that this class, so far, nobody asked me how this 300 point will be given. That actually is a good sign. At least that you know that you want to work hard by yourself. Not actually just trying to ask me, I need to get this point, I need to get that point, okay? That actually trying to haggle or trying to negotiate. Okay, that doesn't make sense. Okay, that doesn't make sense to me. Your main function, your main purpose of coming to this class is to learn, to focus, to learn, to actually learn something, right? Something useful for your future career, okay? For your future career. So you see here, actually, my background, my background image is actually is the UC Berkeley's Campile Tower, okay? So I try to give you the UC's quality of the teaching, okay? But I know that you are private school and actually some of you are part-time. So we do not require you to work as hard as Berkeley, right? We don't. But we do expect you to be able to someday become a very useful person and can actually come to some name brand Silicon Valley company, okay? That's the goal, that's the whole goal that we actually try to achieve, right? Is that okay? Any other question? Any other question? No? Let's see, okay. No more question? Okay.
I guess I have a question.
Yes, go ahead.
Like in my final project, the one I proposed,
Mhm.
what I was doing is I'm modeling a spherical manipulator with a spherical wrist.
Mhm.
I guess like one thing I didn't know of about the time is like assignment 8 is like a cylindrical manipulator with a spherical wrist. I guess I didn't know like those are kind of similar. Is it still okay? My final project that I've been doing?
Have you done the project?
I've been working on it a bit, but
Say you almost done the project, so basically you are almost done with your assignment A, right?
with assignment no, I actually haven't started assignment 8 yet.
Yeah, so basically try to do different project, right? As long as you use different robot, I'm fine. But if you work on the same robot, then what's the purpose of doing that? Right?
Right.
Right.
That's why I'm just I'm a
Yeah,
little
then
worried now because
in that case, you just finish that as a programming assignment A. You need to find something else to do for the final project. Is that okay?
do you have any like recommendations that
You
I could
can
do?
find other robot to do modeling. There are so many kind of robot you can use, right?
Uh-huh.
You can try different robot you can model. Is that okay?
Okay.
or you can, some of the student, okay, I don't know whether I still have it or not. Some of the students do provide modeling in 3D Blender. Let me see, model robot. Some of the students, I don't have the, past project, okay? I don't have the past project for student. Let me see, do I have the, I believe this guy actually is a person, is a student who actually, no, not this guy, okay, I'm sorry. I'm trying to figure out, this is a student before he actually worked completely on mathematical model and then did pretty well. Okay, pretty well. I'm sorry, the past project I may have backup in hard disk, but not available right now. I had to unzip it. Okay, so just try a different robot and you can model it with the software. Okay, 3D Blender or something. 3D Blender, you can use it using the Python to write it, okay? So if you try to use a Python and 3D Blender, there are something that actually you can find, okay? There is something you can find to do modeling for it, okay? There are some even book or software you can refer to, okay? Do not need to just copy the code we have. It's not a project. It's assignment, okay? That's an assignment. Project means that you need to be more creative, okay?
Okay, thank you.
Any other question? Any other question? Okay. So last time we looked at the control loop, okay? And actually, after the control loop can be built by finite state machine, okay? This one we do not actually spend time to do homework, and because this one you need to program the finite state machine. Okay, so there's a video talking about how you control the finite state machine to control your robot. Okay, and so you can watch the video. Okay, today we do not have that much time to go over it, but basically there's how to design the different finite state machine to handle the control of the robot. So last time we talked about low-level control loop. Low-level control loop is for the stability of your for the stability of your robot. So basically, it is controlling the velocity, controlling the robot drive system. Today, the next video that we show is the high-level control system. High-level control system is not controlling a single motor or it's not a single motor is controlled by a transfer curve. You give a certain voltage, you get different force, or you get a different voltage, you get different rotational speed, okay, or torque. That actually is low-level control loop, okay. High-level control loop is different. High-level control loop is the overall, watch over the overall loop control. And so overall loop control require a finite state machine. Okay, how your machine should be moving, how your machine should be doing tuning, how your machine should actually open arms, something like that. So you do need to have a finite state machine, do need to have obstacle sensor, image capturing module. So this whole video that you can see in this A, lecture 1 is motion control. So motion control is not controlling the manipulator, it's controlling the vehicle, controlling your vehicle, okay? Controlling how your wheel turn, how your machine should be driven to where. Okay, that's actually called motion control. Okay, and usually it's using some finite state machine to achieve it. Okay, and there are also Python coding. You can, so this portion is the usually when you do the Raspberry Pi to control your robot, that is the state machine that you are trying to build. Okay, so there are 4 different control approach, model plan X, okay, and strategy based, several one of them, and this whole chapter is to control of the whole loop. Control of the whole loop is called motion control. Okay, and the single state variable that's called PID feedback. Okay, so that's different control loop. One is for vehicle, one is for the manipulator. Okay, so this one I don't spend time because you can watch the video. Okay, you can watch the video, but right here I'm just going over the basic idea of why this video is here. Okay, and there are a lot of system issues. You need to track it and measure it. Okay, but we do not have that much time to go over all this. Okay, we do not have that much time to go over all this. So we have 8 weeks. So my way of doing it is that I try to present in 8 weeks of different topics you will actually experience when you go into the robotic field. So each field we can only have a little bite, very tiny bite on it. Okay, we can only teach you a little bit, very tiny bite. We cannot actually go deeply on certain chapter. That would take the whole month to finish that chapter, and we don't have that much time. Okay, we don't have that much time because we just has a 8-week introductory course. So this lecture 14 is on the motion control loop. Okay, any question? Okay. If no more question, I will be ending here today. Okay. Any other question?
Yeah, I guess I got one more question.
Yes. Go ahead.
Will we be meeting at all next week or no?
Yes.
Okay, it's like still on Tuesday and Friday?
Yes. Sam.
Okay, thank you.
If you still have some other question, you can actually still send me email or Facebook me.
Thank you.
There's one of your friend in this class asked me to write a recommendation letter for him to apply for graduate study. So it's okay. I'm okay. So any question welcome. You actually send me to my Facebook. Okay, my Facebook page. I will answer you when I have time. Okay, my time is actually quite busy, so I cannot guarantee you how fast I can answer you. But usually I try to answer you within like half a day or a day. Okay, is okay? But usually the Facebook is faster than email. And if you have something you want to discuss, still Tuesday, Friday, I still would answer your questions. Okay. Any other question? Okay, no question. That's it for today. Okay. See you next Tuesday. Okay. Bye bye. Bye bye.